The phosphate functionality is a phosphorus atom bonded to 4 other oxygen atoms. There is a linkage to a carbon atom through one of the oxygen atoms. Phosphate chains are found in the biochemicals ATP and ADP. Amines are nitrogen atoms that are bonded to either hydrogen or R groups. A primary amine has 2 hydrogen atoms, a secondary amine has 1 hydrogen atom and 2 R groups, and a tertiary amine has no hydrogen atoms and 3 R groups. A quaternary amine has 4 R groups and it also has a positive 1 charge. The rest of the functional groups listed in Table 4.4 contain a carbonyl group, a carbon doubly bonded to an oxygen atom. The acetyl group is a carbonyl carbon bonded to a methyl group. The acetyl group has 2 carbon atoms, like acetic acid has 2 carbon atoms. Acetyl coenzyme A has an acetyl functional group. An aldehyde is a carbonyl group that is bonded to a hydrogen atom. This means that the carbonyl group must be at the end of a chain. D-glucose has an aldehyde functionality. It also has many alcohol functional groups as well. The ketone functional group is a carbonyl carbon that is bonded to 2 other carbon atoms. That means that the carbonyl group in a ketone is never at the end of a chain, and D-fructose has a ketone functionality. We've already seen carboxylic acids, which have a hydroxyl group bonded to the carbonyl carbon. Like aldehydes, carboxylic acids functional groups are always at the end of a chain. Fatty acids are carboxylic acids, and all amino acids have a carboxylic acid group. We will consider the carboxylate functional group in a later chapter. The ester functional group is like a carboxylic acid, but the non-carbonyl oxygen, which is bonded to the carbonyl carbon, is bonded to an R group, not a hydrogen atom. In an ester, the carbonyl group has an ether functionality and is never at the end of a chain. An amide group is a carbonyl carbon that is bonded to a nitrogen. In biology, they call these peptide bonds, and this linkage is how amino acids bond together to form peptides and proteins.